This tutorial is designed to help you understand what a rational and irrational number are. So before we really get going, we're going to review, so I'm going to talk about these 3 bullet points here. So a natural number is what we would consider counting numbers. So think back to when you were a little baby and you started to learn your numbers. You didn't start counting with 0, you probably started counting with 1. So 1, 2, 3, 4, 5, so on and so on and so on. Those are called natural numbers. Okay? And then a whole number, it is those natural numbers, 1, 2, 3, 4, 5, so on and so on and so on, and it adds the number 0. Okay? And then an integer is whole numbers, so 0, 1, 2, 3, 4, and 5, and their opposites. So I have 0, 1, 2, 3, 4, 5, and goes on, and I have -1, -2, -3, -4, and -5. Okay, so rational numbers, this gets into the meat of the lesson. Rational numbers are numbers that can be written as a quotient, so quotient is division, of 2 integers. Okay, so basically, if I can't write a fraction with an integer in the numerator, the top, and an integer in the denominator, the bottom, then it's not a rational number, okay? But sometimes that can be a little hard for people, especially if you struggle with math. You're like, I don't know if I can write it as a quotient. So I kind of broke it down a little bit for you. So it says examples are integers. So we just wrote that, -1, -2, -3, -4, -5, 0, 1, 2, 3, 4, and 5, and so on. Another example of a rational number is a fraction made of integers. So if you had 1 over 2, 1 is an integer and 2 is an integer. -1 over 2, -1 is an integer, 2 is an integer. Perfect squares and cubes. And then repeating decimals, which we will go over in just a second, and terminating decimals. So those are all different types of rational numbers that you might see. But the biggest thing to remember is that rational numbers can be written as a quotient or a division problem, or you can think even fraction of 2 integers. So I have a little activity that I can do even on this video. I can put out a number, and we can talk about whether it's rational or irrational. So -3, that is a rational number because it's an integer. Integers are rational numbers. 0 is a rational number because it's an integer, and integers are rational numbers. The square root of 2. Well, I know that perfect squares are rational, so let me try to factor this out. And the only factors are 1 and 2. This is a surd. That means it's not a perfect square. So this is not rational, so we would call it irrational. Okay, the next one, 1.23. So this is a decimal that just stops. It's not going on and on and on forever. It's not repeating. It doesn't have the bar over to show that it's repeating. So this is a terminating decimal. Terminating means to stop. So this decimal stops. This is a rational number. I could write this as a fraction made up of integers. Okay, 0.68. That bar at the top means that this is a repeating decimal. So it's going to go 0.68686868 forever and ever and ever. That can be written as a fraction made up of integers. Therefore, it's a rational number. I know I'm going kind of fast on these, but you can always go back and watch the video again if you need to. So the square root of 5. Well, let me factor it out if I'm not sure if it's perfect. The only factors are 1 and 5. That means it's a surd and it's not a perfect square. So the square root of 5 would be irrational. And the reason being that if you were to actually try to figure out what the decimal equivalent of a non-perfect square or cube is, the decimal would go on forever. Negative 6 over 7, the numerator is an integer, the denominator is an integer, so therefore this is a rational number. 3 square root of 2. Well, we had square root of 2 a minute ago and we said it was irrational. So now we have it 3 over square root of 2. Well, this is an integer, so that's good. But this is not. This is irrational, which makes the whole thing irrational. One over 2, integer, integer, therefore it's rational. Just a few more. 1.348 ... That ellipsis is what it's called. Means that this number goes on forever and ever and ever, meaning it's irrational. 4, that's an integer. It's a rational number. Square root of 25. If I factor it out, everything leaves my radical symbol. Therefore, this is a perfect square, meaning it's a radical number. The cube root of 27. If I factor it out, it's 3, nothing inside the radical. So that means this is a perfect cube, which means it's a rational number. And last one, negative 6 over the square root of 9. So the square root of 9 is a perfect square. It's a 3. So negative 6 over 3, those are both integers. So this is a rational number. Okay, you could actually even go further. Negative 6 over 3 is the same as negative 2. If you need to watch this video again, go ahead and go for it.